Are you going to do an introduction, or should I
Oh,
just?
sorry. Yes. No, no, no. I have been chatting while we were waiting for you, but I will continue to chat now. So again, welcome, folks, and thank you for joining us for today's Database in Memory Office Hours, where Andy Ribness is going to share with us more details on automating the management of your database in memory column store using automatic data optimization. Andy, over to you.
Thanks, Maria. Hello, everybody. I do want to remind everyone that on the Database in Memory Office Hours page, we do, if you scroll down, have the links to our previous Office Hours sessions. And then we also have down here other resources. Very often I'll refer to the blog or maybe our white papers, and they are available. And so those links are here. And since you already have the link, obviously, to get to our Office Hours page, that's all available to you. And this will be recorded, so you can always go back and look at it again later. So that takes care of that business. Oh yeah, and if you have questions, just type them into the chat, and Maria will relay them to me because I seem to have trouble trying to present and read the chat at the same time. So so she'll take care of that. But please, if you have questions about database and memory or anything that we talk about as part of our focus today will be automatic data optimization, please don't hesitate to ask. And with that, I put together just a couple of slides because automatic data optimization was first introduced in 12.1, and sometimes people get confused because it's really in 12.1 it was segment or the on-disk objects based. And so we had something called heat map, which tracked usage. So heuristically, the database could know how segments were accessed, and then we had policies that enabled you, the customer, to create policies to, say, move an object from, say, a lower compression or maybe no compression to higher compression, and also to tier data. So if a table space were to fill, you could actually, with a policy, automatically move objects to another table space, kind of thinking of ILM or information lifecycle management kind of policy or architecture, if you will. And so I wanted to point out that ADO started in 12.1, but in 12.2, we enabled it for database and memory as well. And so it's essentially the same framework, but we added new policies, and we actually track in-memory access. It's actually access in heat map, and I'm not going to actually talk much about heat map, so I have at the end some links to some documentation, but the gist of it is that you can then use ADO, or automatic data optimization, to track database and memory objects as well as the on-segment objects. Of course, there is a couple caveats, and let me talk. Actually, we'll just go to that. I put that in a different place, so we'll get there in a second. Sorry. So using heat map or time-based features of the policies, you can, with database and memory objects, you can either populate an object, you can move an object from, say, lower level of compression, maybe the default mem compress for query low, to, say, capacity high. And we talked about compression in another AskTOM session, and we also had a nice blog post about compression, and so we think that's a very reasonable thing to do. And then you can also evict data, say the data that's no longer being accessed. You can have a policy that maybe after 30 days of no access, you can evict that object from the column store. So it allows you to start to create policies to automatically manage the objects or an object's life cycle through the column store. And so that's kind of what we're going to talk about today. And I'm going to do just a couple of slides to give you kind of the mechanics of everything, and then we'll dive into some actual examples. So ADO for in-memory, this actually, I'm going to flip over real quick just because this is actually animated. So the gist of this is, say we have, and this really comes into play mostly with time-based data that maybe you're partitioning. It doesn't tend to make as much sense for single objects, although it may, especially in the case where you might have different workloads, where you might have policies for actual objects. But in general, time-based, kind of a rolling window partitioning scheme tends to make sense. That's what this example shows. We have the sales table with multiple quarters, and we have a policy that's going to evict, maybe, there we go. It's going to evict a partition and then automatically populate another partition. And so you can imagine this is just a rolling window using ADO policies that then can automatically keep your most active, in this case, sales data in the column store without you having to physically issue commands to do all of that. And that's kind of where the power of ADO and what makes it interesting, I think. And so that was kind of the example. I'm going to go back to regular mode though here, just because it seems to be easier to operate. And then with database and memory, with ADO for database and memory, you have to have in-memory enabled. It is compatible parameter must be 12.2 or higher. And then heat map actually has to be enabled as well. And so that kicks in the ADO functionality. Big point, though, is that that's what I was kind of getting around to saying initially, is in 12.1, ADO was part of the advanced compression option. So you had to license advanced compression. And now in 12.2 with database and memory, with database and memory and your licensing there, you can use ADO with database and memory. And this tends to be a little confusing. And so I like to make sure we pointed out that it does not require the advanced compression option to do this. You're entitled to do this as part of database and memory. And that's the prerequisites. Then, as I said, there's 3 policies available. Set in memory, which is what, if you run that policy, it will enable an object to be populated in the column store. Modify in memory, it will allow you to take the compression level from lower to higher. So we don't go from higher to lower. It's got to go from lower to higher. So my example would be mem compress for query low to say mem compress for capacity high. And then the third policy is no in memory. So you can then evict an object. It'll remove the in-memory enablement, and then that object will be evicted from the column store. And then you can add criteria. So with heat map or with based on time access. So either after a certain time period, we can say no access, that it hasn't been accessed. That would be a heat map query, because we would go to the heat map and say, has that object been accessed at all? Creation would simply be date. So basically from maybe after 3 days of creation. And then no modification, again, the data hasn't changed, and that would also be heat map based. And then you can also do it based on a function name. So you can actually code a Boolean function. You can actually write your own criteria within a PL/SQL function, which is actually pretty powerful. And then the policy names, when we do our example, the policy names will go from P1 to P2 to PN, and that's not controllable, but that's just how you can then differentiate the different policies.
Hey, Andy, we've got a quick question for you, if that's okay.
Yeah.
When you talk about the fact that we can use these policies to change the compression level within the in-memory column store, do we need advanced compression in order to be able to use that aspect of the feature?
So no, you don't. The compression for database and memory is different than advanced compression, and it is all part of database and memory. So you don't need all of the ADO associated with database and memory. Is standalone, doesn't require anything with advanced compression, including the in-memory compression level changes.
Awesome, thanks.
And that always confuses people. That's why I pointed out, and I'm glad you asked the question, because that always winds up being confusing.
Well, don't thank me. That was a question from our viewers, but I appreciated the clarification, because you're right. As soon as you hear compression levels, makes people a little nervous that they may need additional licensing when they don't.
Exactly. So, and then, and so for the policies, since it's part of ADO in that framework, policies run on a daily basis. within the maintenance window. But it is possible to run the job or evaluate the policies outside of the maintenance window using an API, DBMS, ILM. We're actually going to do our demos that way because we obviously don't want to wait around for the policies to be run. And we've got a couple ways so you can actually evaluate in a demo environment how this works without having to work within the daily, waiting for a day for your policies to run. They are run through the job scheduler, and there are views to look at that you can look at to see what's been run, and we'll go over that. One of the things to remember is that with ADO, and again, this is part of the framework, so this counts for all of ADO, we have 2 levels of policies. At the table level, and that's really only with the on-disk options, which I won't really talk about. All of the in-memory policies are segment-level policies. And the implication of that, or what that means, is that the policy then will only be run once. And once it's complete, once it runs successfully, it's then disabled. So it will only run once, it won't run repeatedly, which is actually good because there's if you have added an option, or an object, you don't want to keep adding continuously. So we operate on the policies at the segment level, which implies that they only run once and then they're disabled. And then lastly, policies typically are created on the segment, but can be inherited from the table space. And I'll talk a little bit later about why you might do that. But it is possible, just like with say partitioning, or with database and memory, where you might want new partitions to automatically be enabled for in-memory. It's possible that you might want that to happen, and you can do that by enabling in-memory at the table space level. So it picks up the default when the object's created. And so that's kind of what I wanted to point out there. And then we're just going to show a couple of examples. We're going to use these examples in our demonstrations to show you how this actually works. But I have an example of a set in memory. So after the object has been created for 2 days, so we've created it, 2 days have passed, the policy is then going to enable that object for in-memory, in this case, the customers table. So then database in memory is going to then populate that object in the column store. And you might do this because, say, you're doing a lot of data loading and you want to go ahead and do that loading. It's not ready to be populated in the column store because you're not ready to do both analytics against it, or you don't want to have the database in memory have to keep all of that up to date and in sync. And so that's just extra work that doesn't need to be done. So say after 2 days, we've loaded the data, we're ready to take a look at it, and we've created a policy that says we're going to go ahead and populate it in the column store, so we don't have to do our alter table in-memory command. Then the second command, or the second policy we'll have, is modify in memory. So I said it does enables objects, compresses, and evicts, and so we'll do our compression. So after 5 days, now I've cut this down, but realistically you might have 5 days, 30 days, some period of time where the data is no longer being modified, just queried, but you also want to have more space in the column store because you have more objects you would like to load. So we're going to go ahead and say after 5 days, let's modify that object to capacity high. So we're going to increase the compression level. That will basically require the database in memory repopulate that object at the higher compression level. And then lastly, say after 20 days, we're going to evict the object. So we're going to say no in memory. And so when nobody's accessed it for 20 days, we're going to evict it. So it's actually not 20 days since creation, but 20 days since anybody's queried the object. And that'll be based on, again, heat map. So when nobody's accessed it for 20 days, obviously it's just taking up space and it's not important to be having the column store. We could use that memory for something else. So there's our 3 examples that we'll use. And that's basically the syntax. It's as simple as that. And then I did put in here a quick example of the Boolean PL SQL function. it's a little confusing, I think, in the documentation, so I threw it in here. We won't really do anything with it, but you can go back and perhaps use that as a template, if you will. Although literally all I did was create the function. It's interesting, you have to specify a number as an input parameter, as the object number basically, but you don't actually have to do anything with it. ADO takes care of that. And then you can put your PL SQL code in here, which I didn't, I should have put a begin end in there. And then ultimately though, you have to return a Boolean value, true or false. And then the policy then accepts that. If it's true, it'll run the policy. If it's false, it will mark it as not set or not eligible to be run, and will reevaluate it again at the next cycle. And then the actual syntax let's get this out of the way. The actual syntax is the same as we did, add the policy, same as we had done before. This case would be modify in memory. You could do set in memory, or you could do, I already forgot what the other one was. No in memory, sorry. And, whoops. And then we say mem compress for capacity high, so that's our compression policy. But now we're going to do it based on our own PL SQL function that's going to go and maybe evaluate some other information and decide whether or not that makes sense to go ahead and populate that object yet, or I'm sorry, compress that object to a higher level.
And so, Andy, that could be any kind of business logic you've got, right? Exactly. It doesn't have to be based on DML. It could be based on, waiting for certain transactions to finish, or status of your own application code, right?
Yeah, maybe you're waiting for a message from a queue, advanced queuing, and you dequeue a message that says, okay, we're all kind of done with it as far as modifications, and so your application sends a message, and now you can go ahead and compress it because you're only going to query against it. Yeah, so any business logic, maybe checking of something, looking for messages, whatever you want to trigger that policy based on. So that's actually pretty powerful. And then there are multiple views. Well, most of these we'll use. I have several queries that we'll go through, so I'm not going to really spend any time per se, but I listed them out so that you'd be aware of them. And they're corresponding DBA or user views, so you can do it with DBA underscore ILM tasks as well as user. And so we're gonna go through most of these in the demo. So like I said, I'm not gonna spend any real time other than to make you aware of them. And then there are two packages we will use. We will use them because we're going to use the DBMS ILM packages to actually run our policies individually, since we're doing a demo. Normally you wouldn't have to do that, but you could run your policies on a more frequent basis if you wanted to than in the daily maintenance window. And then there's a bunch of heat map policies, the admin, that typically you wouldn't need to use, but if you want to go look in the PL SQL function and package guide and look at all of these, you're more than welcome. These two packages are associated with ADO, basically. And then lastly, I'm going to put it up here so I don't forget, there is more information. Most of the ADO information is available in the VLDB and partitioning guide. Go figure, that's where it got lumped into. Our database and memory guide, which came about in 12.2, which is where this becomes available, it's also documented there, the in-memory part of it. And then the database reference has initialization parameters and those dictionary views that I mentioned. So those three resources pretty much tie all of the information you need to basically use ADO and find out all of the different aspects that you might need to know in order to implement it.
So I've got another question for you, Andy. If you can go back to slide 10, I believe, had your, oh, nope, sorry, it must be slide 9, the one that had your example, where you're doing, that's it, modify in-memory mem compress for capacity high. The question there is, just to be clear, we're only changing the compression level within the in-memory column store and not for that object on disk. Because capacity high could also be an HCC compression level, so that I think might be where
yeah, no, it is, but it's only in memory. So modify in memory. So, and then this is a in-memory compression level, because mem compress. So yeah, it won't affect anything on disk, which is kind of how database in memory works. And so it's only for, and actually these as well, only for the in-memory portion of the object. So it leaves the disk part of it completely alone. Right, so if it's HCC compressed or advanced row compression, it doesn't change any of that.
So I could do both if I wanted to, I guess. I would just have to have a separate policy, one for the on-disk storage of that object and one for the in-memory part.
Yeah, absolutely. You can do, not to get onto the disk part to confuse anyone, yeah, you have a lot of flexibility with different policies, and they both can coexist because they're really operating on different aspects of the row store and then column store. You know, our picture where we show the row and column. And so they are, even though they use the same framework, the policies themselves are completely separate.
Great. Thanks, Andy.
Yes. So if that's all the questions for now, let's dive into some examples. So what we're going to do is we're going to use the examples of that I laid out, those three policies, and we're actually going to run them. We're going to create them and run them and see how all this looks. I've pre-scripted this so you don't have to watch me type, which has kind of been my mode of operating on these AskTOM sessions. So the first thing I was going to do is just show, oops, I did. Just show, so we're going to use the customers table for the whole example. And so I'm just going to show you where the in-memory settings are currently for our customers table. And so it's currently not enabled for in-memory. So obviously then no priority, no compression levels. And I do have, I'm going to break my, and so I realize I don't have that in here. This is just a script I use that just shows what's in the column store currently. So I emptied the column store. It's rack aware, but that's not relevant. But I basically queried our $im segments view, and we have nothing currently populated. It makes it easy for us to take a look at this. So now what I'll do is I'll go ahead and create our three policies. I think I could do a middle button, but so we're going to set in memory priority high. So we want it, if we're going to enable it for in-memory, we want it to automatically populate. And so we will set it with enabled for in-memory. We're going to set priority high after 2 days of creation, just like I had in the slide. And then I'm going to create the second one. Actually, I'll just do the third one as well. We'll do it all at once. So what I've done now is said, go ahead and modify in-memory mem compressor capacity high, so after 5 days of no modification, and then alter the table, and we're going to evict it after 20 days of no access. So those are our three policies. So you might say, well, so how do I know what policies I've created? And let's take a look at that. So I'm querying user underscore ILM objects. Again, all the views are documented, and there are examples in the in-memory guide, or you can come back and look at this if this makes sense. But now we see that I have three policies. Notice the policy numbers aren't 1, 2, 3. I practiced this, so hopefully it'll all work. And so we're up to 19, 20, and 21. And we see that it's on the customers table. And it's not inherited, and they are enabled. So that's enabled, that guy right there. And but you might say, well, okay, I see we have three policies, but what do they do? So let's take a look at, of course, we have to have another view to see that. And you could write a query to do all this in one. Whoops, I was afraid of that. I may try to make the text on the window big enough that we, I always find it hard to, let's see if it scrolls all the way across. Ah, yes. I always find it hard to look at it when it goes across. So we see that our three policies, 19, 20, 21, we have creation, last modification, last access time, a policy is in memory, and then we see what the action was. So in memory, priority high. So that's going to be our enabling the policy to enable the object for in memory. And then we have our second one, which we created, was we're going to change the compression level to high, and then no in memory, we're going to evict it. And we see the number of days. So you can piece together what the policy is between, well, the first one tells you what they are, but so does this one. So basically this view kind of tells you what your policies are doing. And so that takes
Andy, can I ask you two quick questions?
Yes.
One on the policy name. That's a system-generated name. I can't name my policies, can I?
No, you can't name them. They just increment, and the value is just that you can then differentiate the individual policies, kind of like a primary key. But yeah, you can't control that. Even if you want to, you can't.
And if you scroll back up again, you mentioned that I could see the inheritance. And just to clarify, that inheritance is if I inherited it from the table space?
Yes, so that means that you didn't specifically create the policy individually. You just, that when the object got created, it inherited that policy from at the table space level, the table space default level.
Okay, great. So it just basically means each one of these was explicitly set on the customer table rather than just being inherited from the table space it was created in.
Right.
Okay, cool. Thank you.
Yeah. Let me move this down just a little bit. All right, so that basically, we've created our policies. Now, in a perfect world, these policies would be evaluated once a day in the maintenance window. So whenever the maintenance window opens, then those policies will be evaluated, and if they meet the criteria, they're implemented. Otherwise, they're saved for the next time. So, but we're going to bypass all that because we don't want to hang around here for a day to see this stuff run. So I hesitate doing this, but in the interest of full disclosure, there are parameters, and they are documented in the VLDB guide, and one of them is called policy time. So I cheated. There's an ability to have a policy. I have them here. You can set the policy time. The default, the normal expectation is it runs in days. We've done this demo. I've done this demo with ADO before. We've talked about this. I've talked about it, not within memory, but you can change the policy evaluation to be in seconds, which is what I've done. I literally just ran this command, change it in seconds so that we could actually go through and look at these policies individually and see them run so we don't have to hang around. So you normally wouldn't do this, but this is strictly for demo or maybe troubleshooting in a demo environment. If you want to go through and get comfortable with how this works, you don't have to hang around for a day to get this to work. It'll evaluate the policy based on the number of days being 2 seconds rather than 2 days. So hopefully I don't confuse everyone, but I kind of like to point that out because you're going to probably come back and ask, well, how come it evaluated this and worked when it says, well, it won't do this for 5 days? So it looked like a question came by. Do we need to do anything?
Sorry, if I wasn't on mute. Okay, yes. So the question came in saying that if the ADO policy applies the in-memory attribute, to after the criteria is met, so in your case, 2 days after it's been created, let's put it in memory, does that in-memory property persist on that object?
Yes, and I'll show you. Yes, it's literally an alter table in memory, and it's associated with the in user tables. You'll be able to see it, and yes, it persists just like any alter table command would. It's essentially DDL, and so it's operating on that. It'll always be enabled for in memory until you either disable it with alter table no in memory or another policy to do the same thing runs on it.
Okay, so it will be repopulated the next time the database starts, or if it gets until it's actually explicitly evicted via a policy or by command.
Yes.
Right. Perfect. Thank you.
So we're going to run our policies, but we're going to do it, since we're not going to wait for the automatic part, which would run once a day. We're going to run using that, as I mentioned earlier when I showed you those APIs. We're going to execute the ILM, and we're going to do it based on an actual policy name, because since we've already been talking for longer than 20 seconds. So in theory, if I just ran this like we would run in the in the maintenance window, all the policies would run, and we wouldn't see what we want to see. So so you have the ability to run a policy individually on demand. So if, say, you didn't want all of the policies to run, you just wanted policies just to run the policy against a particular user and see if that policy's met its criteria and have that run, you can do that. And so that's what we're going to do for the demo. Again, this is just demo. Normally you don't do any of this. Once you create the policy, you can walk away and it'll all be handled automatically. However, in the interest of time, we're going to go ahead and just try these out. So let's take a look at, so we have no current policies run, but we're going to keep this in mind, so we're going to come back to look at this. And just as a reminder, we currently have the customers' table is not enabled for in-memory, no priority, no compression set. And so, and I already ran this. Nothing's populated, nothing has changed yet. And one more view. We have our policies again. This is the same view I showed before. And we're going to run this guy, P19. So as I put my note here, change the task IDs to match. Oops, P19. And I didn't put my quotes around it. And I probably should have just gone ahead and run this rather than running those other views because I got out of sync. So let's go ahead and run our first policy. So procedure successfully run. Remember, we set it to 2 seconds, and it said after it's been created for 2 days, in our case 2 seconds, we should see that the policy has been enabled. So let's go back and, whoops, rerun these that I should have run. I know Maria's going to get nervous because. So we've selected it for execution. So this is the ADO portion of it. We've selected it for execution. And now in the database, we notice that now it's enabled for in-memory. Priority is high, because I said in the policy, set the priorities we want it to populate. And then we took the default mem compress for query low. So that policy changed that. Great, everything's hunky-dory. So with any luck, it will be populated. And it is. Notice, we'll come back to this, but notice the in-memory size is 5 megabytes. And then we'll go ahead and take a look at this. So notice now with our policies that the first one's no longer enabled because it's a segment level policy, it ran successfully, and so it's already been run. And then lastly, we'll run, these were basically to show us now, we can look at the results of the running of, oops, what did I do wrong? Oh, maybe I, oh, task ID, oh, shoot. Sorry about that, guys. I screwed that up because the task isn't the policy name. Let's just do this. The task ID is different, and we'll just show you that. So the task IDs, I've run this before, is actually going to be the most current. So it's actually 237. And what I had in for the example, I got to put it here. Was just so that we wouldn't have to look at all the extraneous data. So we look at the ILM tasks. We see that that task ran. And how come our results, did I miss that? Oh, because it was still in the buffer. There we go. And so what happens is a task gets scheduled through the job scheduler, it evaluates the policies or policies associated with either the once a day run, or if you manually run all the policy evaluations or run them based on what we did, one policy, creates a task. So it can be multiple jobs within a single task. And then what I've shown you is the job that ran. So in our case, we had one task and one job that ran. Notice that the job that ran, so the view was ILM results, ILM tasks, and we see that that task ran, and then it fired off a job associated with that task. Could be more than one job, in our case just one, and then that completed successfully. So that's the way you can see what's going on under the covers in the ADO portion of it. Hopefully I didn't just confuse everybody because I messed up on my task ID, but these views are available. And to be honest, you got to go play with it. You can use my example. There's nothing special about any of the stuff we're doing here, and you'll be able to see in the, and I'll put this in the presentation. I'll make this available so you could just cut and paste this yourself, because that might be useful rather than trying to get it out of the video. So I'll make that available on the AskTOM website as well, the command. So you can actually go do this. It's very simple. Developer days or whatever database you have available, and you could go play with this and see how this works as well. So not the smoothest thing, but I think we get the point across.
No,
so
it was great, Andy, but I have a quick question for you that came in over the chat. One of the questions was, for folks who do a lot of IoT style workload where you're really only interested in the data for a very short period of time, and it would be great to automate that process of bringing it into the column store while we need to run analytics on it, but getting it out very quickly. Do we have the ability to change that timing? You said we could change it to seconds or to days. Is hours an option, or would I have to get kind of creative with my math and use seconds, but with large numbers, like 3,600 seconds or whatever for an hour?
Yeah, there's only days, and really seconds is really only meant to be used for testing. Although I guess you could do it. I've never heard of anyone actually using seconds normally. But to be honest, in that kind of to want that kind of flexibility, it might almost be easier to create a scheduler job that runs maybe every 15 minutes or every hour and just reruns this command but runs it for all of the tasks. So rather than your daily running, maybe you run it every 15 minutes and it's just in a single scheduler job that just repeats and just runs all of the policy evaluations, and then the ones that meet the criteria just work. That might be a simpler way to handle that.
Okay, cool. Thank you.
Sure. So let's move on to our second.
Sorry, hang on. I have a second one for you.
Okay.
So when a task is complete, it's disabled. When we reboot the database, do you have to manually enable those policies again, one by one, or will they ever become enabled again?
Yeah, so this policy, since it's been run, will never become enabled again. These won't, if you recycle the database, that doesn't change the status of these two remaining policies. They're still enabled, and they still potentially will be evaluated during the policy evaluation window. So, and that's because it's a segment level policy. So, but what this policy did was it enabled it for in-memory. So if the database was to go down and come back up, since it's enabled, it'll get repopulated in the column store. So if you want, I guess I'm trying to think of a case where you would want to run the policy multiple times for the same thing on the same object, and that's kind of not the way that's supposed to work, I guess. So the answer to the question is no. Once it's run successfully, it's disabled, and you would have to create a new policy if you wanted to redo that policy again on that same object.
But the effect of the policy is persistent, right? Because that policy was to mark the table for in memory. That attribute remains through the database shutdown and restart. So the action of the policy persists.
Correct. It's just the policy itself. The invocation of the command is a one-time thing.
Okay. No, I think that makes it clearer. So if I define a policy and it successfully executes, it's disabled and can't be enabled going forward. I'd have to create a new policy to try and do the same thing over again if I needed to.
Right.
Okay.
Which is where the inheritance might come into play if, say, you have rolling window type environment and you want it to run for each new partition that comes into play. So you don't have to create them all. You can just let them inherit from the table space. I'm pretty sure 19, 20, 21, right? Yep. So, so we have the object. I'm just going to do them both. We have the object, the customer's tables. It's populating the column store, and it's taking 5 megabytes of space, and the compression is query low. So now our second policy we're going to run. I changed it to 20. And it's going to run because, again, seconds, we're manually enabling it to be run. And now let's take a look at what happened. Okay, so this is how you can figure out the task ID. Basically, you just ILM evaluation details. So 238 is our new task. It was selected for execution, which is good, which means it passed the criteria. And now we're going to do, so now I'm going to do the demo part correctly, I hope. So we'll get all of this, which is what I should have done the last time and messed up, but you know. So the task completed, and we're looking at, this is all ILM results task. So this is all for the ADO. We could have called it ADO, we called it ILM. So think of ILM and ADO as being synonymous in this case. And the job completed successfully. Again, one task, one job. And let's see the result. Oh, there we go. And so it's still enabled, still priority high, but we changed the compression level to 4 capacity high. And that implies that we repopulated the object. If we change the compression level, it means the object will get repopulated. And notice now that it only takes 2 megabytes rather than 5 megabytes. So it actually did what we wanted it to do. And so that's the second policy. And we can actually go and take a look at our objects. And we see now that the second one has also been run, so it's no longer enabled. But the results of it, if we recycle the database, it's going to repopulate it with capacity high. And so now that can live for, in our case, until we meet 20 days of no access, which in our third task is going to cause that object to be evicted with any luck. And so we'll go ahead and run this. And again, normally this would just run on a daily basis, or if you have a job that's going to run it every 15 minutes. And when the criteria is met, they're automatically run. We're just doing this because we're trying to elaborate exactly what's going on under the covers. So we have a new task, ID 239, selected for execution, which means it met the criteria. So let's take a look at our task and job, make sure that ran correctly. Oops, there we go. And we see that the task ID, user ILM tasks, ran 239 completed. It kicked off a job, and that ran successfully. And so now if we look at the status of the in-memory parameters for our table, we see that it's been disabled. So now that should be evicted from, effectively, remember, it doesn't, the ADO policies are literally only doing alter table commands in essence under the covers. And so all of the population, recompression, or eviction is all handled as if you had done it by hand. And so so that's kind of the nice thing about ADO is it doesn't affect any of the actual operations of in-memory. It just enables all of this to occur with the same mechanisms that work when you do the commands on your own. And let's see if, in fact, it did get evicted. It all worked, other than my first mess up with the task IDs. And so it's been evicted. And so that's literally a life cycle of an object. We loaded the data in it. We, after 2 days of no modifications, we populated it. After 5 days of after 2 days of creation, we populated it. So we loaded it. After 2 days, we populated it, in our case, 2 seconds. Then after 5 days of nobody modifying it any longer, we went ahead and compressed it to a higher compression level, got a pretty good compression from 5 megs to 2 megs. Then when nobody accessed it or looked at it for 20 days or some period of time, we then evicted it. And so we literally, that would be a life cycle of the object through the in-memory column store. And then, of course, with the other part of ADO, you could also manage the life cycle of the object on disk. But again, they're completely separate. They don't have anything to do with each other, and they don't require any other licensing. You have your in-memory, and then you have your on-disk stuff. And so that's still always separate. Does that work? Did I hope you think I got everything in there?
No, I think you did. I think that was awesome. I'm actually very excited to automate the management of my in-memory column store at this now. And you said you're going to share that great script you were using.
Yeah, I'll share all these commands because, I mean, I can flip through them here, but nobody's going to want to try to figure that out. So the beauty of this is the customers table is actually part of the sales SH schema. So, but you could use any table you want. You could just create some dummy table. As long as it's big enough to get populated in the column store, it's got to be bigger than 64K. And then you can run all these commands, enable heat map. I have all of that in the presentation, the prerequisites. And you can play around with this to your heart's content in your own database, maybe on your own laptop, and take a look at it. And as a teaser for folks to come back and watch another AskTOM session, we have a new feature called Automatic In-Memory. So in addition to ADO, and that's what we're going to talk about next time, how do I let the database just manage all of this? Let it just do all of this work. Say for objects that I'm not really sure whether they should be in the column store or not, with this heat map data, we can let it just automatically do that for us. And so we'll start to talk about where we are with AIM and the features that was first introduced in 18C, and we're working on some enhancements to it. So it's actively being developed, and so we're going to talk about that. I think it'll be an interesting session for next time.
Excellent. So like a self-driving in-memory column store.
Yeah, right up your alley, right?
I like it.
Yeah. So that's where we're headed. So we want, and it makes sense if you think about it, the database ought to be able to do a lot of this work on its own because it's already keeping track of it all. And so that's kind of part of the autonomous message. Although initially ADW has database in memory, but it's Flash-based, the Flash portion of it. ATP doesn't currently support in memory, I don't believe, but I don't know what the plans are there. But the autonomous, but if we allow it to automatically occur, then it kind of fits into that puzzle, which is another reason for taking a look at this. So we'll see, but we know things are evolving. And certainly even for on-premises customers with EXA, this makes sense to manage the column store continuously, or cloud customers. So with that, I think unless we have any other questions, we can kind of wrap this up. And I think we've got you a good teaser to come back and visit with us probably next month, or I don't know whether we're scheduled for June or July, but our next session, the focus was going to be on automatic in memory.
And you can find details on the upcoming sessions on the AskTOM website, on our Office Hours website there, and on that tab. So as we move into the summer, it's always going to be a little more exciting with vacations and stuff, but we'll post it there on the AskTOM website.
Oh, darn. So you know what I may wind up doing? I'll put a note on the AskTOM website. I may wind up putting the script. I thought I had it up in a browser window, but I guess I don't. The script and maybe the presentation under our AskTOM, because I have a link to the AskTOM information. I think I can put it in the resources page on our AskTOM page. If not, I'll link it and put a note to our DBIM resources page on the blog. But I will make both the presentation, because it has all those prerequisites, and this script with all the commands. I'll make that available either on the AskTOM page. If I have trouble with that, I'll put a note to the effect that it's out on our DBIM resources page on the blog. So I'll make those available either later today or tomorrow.
Awesome. Well, thanks, Andy, and thanks, folks who've stayed on for the entire session. Everything's been recorded, and we will post the recording as well on the AskTOM website. So thanks so much for joining us. Hope we see you next time.